this was a hockey game, we'd be in the third period because we are on our final video of our rays, angles, and lengths series. We're going to talk about lengths in this video. Now, another word for a length is a line segment. Line segment's just a piece of a line, right? It's finite, not infinite. And we will always talk about line segments in terms of their endpoints. So, for example, line segment AB, we would write this. I can get brush up. AB with a little line segment over it. Notice there's no arrows. Okay, now the diagram, the way I would draw this would be if I have point A and point B, that's segment AB. It wouldn't matter if I had another random segment on here. You know, if I had something like X right there, I would still call segment AB like this. I wouldn't call it AX or AXB. It would just be AB. You could talk about segment AX or segment XB, but not segment AXB. Okay, the length of a line segment, AB, which would be a number, we just write, instead of writing the line over it, we would write AB is equal to 3. So with the length, there's no line. We're talking about the actual measurement. Okay, let's talk about congruent line segments. Now, congruent line segments are line segments that have the same length, right? They have the same measure. And remember, congruent means same size and same shape. We talked about that in our last video. Lines always have the same shape. So here we're just concerned with them having the same size or the same length. So if AB and CD are congruent, we would draw these little congruency lines. Remember, if you had multiple sets of lines that were congruent, you could do something like 2 lines or 3 lines like that to show that they're congruent. But since we only have one pair of lines that are congruent, we're just going to use 1 dash for each of them. So here we would either say AB, the segment AB is congruent to the segment CD. Remember, we say that when we're talking about geometric objects, right? These are 2 geometric objects. They're congruent to each other. If I want to talk about the lengths, I would say that AB is equal to CD with no segment over it, right? Because AB and CD, I'm talking about the length there, the measurement. Yeah, so that's really it for congruent line segments. Again, if you're talking about the line itself, we use congruency. If you're talking about the length or the measurement, then we'd use the equal sign. Okay, skipping over a little bit, let's talk about a few other things. The midpoint of a line segment, that's the point at the center of a line segment. Cuts the line segment into 2 congruent line segments. Okay, so here we go. Let's draw a line there. We have, we have A here and B here. And let's say we have a midpoint out there at midpoint M. That would make that congruent to that. So in this one, we would say AM segment is congruent to MB. And well, we'll talk about this later, but if that's true, then M is the midpoint. Okay, to calculate the midpoint is smack dab in the middle, right? It's right in the middle of those 2 points. So if we're on a number line, to calculate the midpoint, we would find the average of the coordinates. Let's do a quick example. Draw our number line. And let's just draw a few ticks on here. Just kind of, we've got one here. Try to get the brush out. Playing with me today. Okay. Let's do just a few tick marks. Try to get evenly spaced if we can. Okay, so let's say we start at 2 and we go 3, 4, 5, 6, 7, 8, 9, 10. Okay, this should be interesting. So what is the midpoint between 2 and 10? Well, if you just kind of want to count, you could say, okay, 2, 1 over is 3, 1 down is 9, 1 over is 4. We go to 8, 5, 7, 6, and 6, right? The distance here is 4, right? 1, 2, 3, 4. And the distance here is also 4. Because if you have a number line, that's nice. You can just count, right? And find the midpoint is 6. Or we could take the average. Now, to find the average of a number, so let's say m equals the average of my coordinates, 2 and 10. So that would be, we add the numbers together, 2 plus 10, and to find the average, you divide by the number of numbers you added. So we added 2 numbers together, 2 and 10. So 2 plus 10 divided by 2 is 12 divided by 2, which is 6. And that's our midpoint, right? That's what we thought it would be. So this is the easy way to find the midpoint of 2 coordinates. And we'll get into all that later with midpoint formula. Have a ton of fun on the coordinate plane. But for now, this is what you need to focus on. Okay, I kind of hinted at this, but if we're looking for distance on a number line, you subtract the coordinates and take the absolute value of the difference. Okay, so if I wanted to find the difference, the distance between 2 and 6, I could just do this. 2 minus 6, that's the absolute value of that will be my distance. 2 minus 6 is -4. And the absolute value of -4 is +4. So the distance is 4. Another example, if we did the absolute value of 10 minus 6, well, that equals the absolute value of 4, which again, absolute value is always positive, so that's 4. So using this, we can see the distance is just when you subtract the coordinates. Okay. Now, one more thing about line segments. The bisector of a line segment could be a line segment, a ray, or a plane that intersects the segment at its midpoint. Okay? So let's draw a line here. We'll put points A and B, and my midpoint here, M. So to bisect it, it needs to intersect at the midpoint. So a ray that bisected this would look like this, right? Cuts it straight in half. So that would be a segment bisector if it cuts it in half. And it doesn't even necessarily need to go straight up. It could even be, the ray could have even started down here. Oops. Right? As long as it passes through the midpoint. Oops. As long as it passes through the midpoint, then it's a segment bisector. So we call this a segment. Oops. Segment bisector. Now this could also, right, it could have been a line. So it could have been a line. It could have had arrows at both ends. Or, right, it could have been neither of those things. It could have been just a line segment. Or if we really got crazy with it, it could have been, let's just draw it, I guess. Not get too fancy with it. Could have been a plane. I can figure it out. Could have been a, So it could have looked like that. right? Plane bisecting my line. Something like that. Not the prettiest thing, but it works. Okay, so that concludes our segment on rays, angles, and lengths. I hope you found it helpful. And if you need any more information on any of those things, remember you can always go back and watch a different video.